Really. Read it and think about it for a second. A few seconds. That's Chem 2A, really, after the questions. It's material from Chem 2A. But the way we do it, a lot of people reach the fourth year, and the distinction between acid-base, Burstyn-Lowry, acid-base reactions according to Burstyn-Lowry, Arrhenius and Lewis is very confusing, unfortunately, and it's not your fault. It's not really clear in the books. 2012, by the way. Very hard to believe it. There's not quite agreement about correct terms. That's why there's so much confusion for students. They should read it one time and then forget it and understand. It's so simple. Why students do not know the difference after the fourth year? We're doing something wrong. We're doing something wrong. So, what is the answer here? In order to really answer this question, right, you must master very correctly the concept of acid-base according to the three definitions. Otherwise, you can answer. Could water act as an acid or base according to Lewis in this reaction? He doesn't say water, because the question could be water, the water molecule could react as a Lewis acid or as a Lewis base. That's a different answer to the question. This is in this reaction. Does water act in this reaction as a Lewis acid, Lewis base, Burstyn-Lowry base, reducing agent, oxidizing agent? Is it? Does it? So what's the answer? How many people say A? Let me see how we can get at this. How many people say A? B, C, D, E. Well, you know what? We're doing something seriously wrong with our education system. Okay? If you are guys to see, and I don't blame you, we blame us. Third portion of 2C is 2C, and we cannot answer a question about acid-base reaction, what it is in this case. We are doing something really wrong. And this has to be said maybe many times out there, but I don't know why it's not done. We need to change a lot of things. Start analyzing this now will take 15 minutes. It's not going to be a review session that way. See what happens when we start wrong? When you start building on the sand, right? Then it's not easy to demolish the house and start from the beginning. It takes a lot of time. You have to start from the rock. Well, let's see from the beginning. Oxidizing agent. If it's oxidizing agent, right? Oxidize something, what itself is reduced. If it would be reduced, we'll have an element that its oxidation number should decrease algebraically. Do you see that? Oxygen has -2, it goes to -2. Hydrogen is +1, goes to what? +1, but also 0. Right? So from +1 to 0, that's algebraic reduction. So, is that an answer? Why not? We said it's an oxidizing agent, oxidizes, that therefore something is reduced, an element is reduced, and should have an algebraic reduction, at least one element of its composition. And we saw that it is. Hydrogen goes from +1 to 0. Doesn't it? Yes or no? Okay. Then you can say that it seems like it's acting as an oxidizing agent. As a reducing agent, it should reduce, something should be oxidized, algebraic increase, but you can see there's no algebraic increase from +1 to what? +2 or +3. You don't see any hydrogen +1, +2 there, do you? And oxygen is -2. You don't see any oxygen here with 0 or anything else like that. No. Okay, so the answer should be A. The thing is, to understand this problem, you should really know why these things are not correct. That's, and you know, that takes a lot of time to see it. Notice that this problem does not give you the choice of Brostman-Lowry acid. It does not give you the choice of Brostman-Lowry acid. How about if I ask you right now, does water act as a Brostman-Lowry acid, this reaction, yes or no? How many people say yes? How many people say no? How many people say do not know? Lift your hands. All the way up. How many people do not know? You see, when you have a reaction, you can classify it in many different ways. It doesn't have to be one classification. So, one classification was it's a redox reaction, yes? But also, if you really look at it carefully, it is also a Brostman-Lowry acid-base reaction. It is, at the same time, a Brostman-Lowry acid-base reaction. Why? There is a proton transfer, isn't it? Oh, yes. How many people can see that it is a Brostman-Lowry acid reaction? Raise your hand. And we should do it. When you say calcium hydride solid, that is an ionic compound, you know that. Metal, non-metal, it's ionic bonds. Okay, so basically the hydrogen here is in the form of what? Hydride. Like this. And when you have water, this, that's with the way you will do it in organic chemistry, when you go to organic chemistry. This will pick up that hydrogen as proton. So a proton transfer will go from here to there. Proton transfer, H plus, will go from water to H minus. So what's going to happen? Hydrogen, or H2, gas, and what remains will be what? Minus. And that's what you see. Hydrogen you see, and H minus. So there is a proton transfer from the water molecule to H minus. That's a Brostman-Lowry acid reaction. Water is acting as a Brostman-Lowry acid. Hydride ion is acting as a Brostman-Lowry base. Okay, down to the first